Hello guys. So, in a continuation with the atomic structure, till now we come up to the a different story of structure of atom as given by Rutherford and Thomson. Now we are going for the actual calculation part, and the theories become more and more precise. Now what do you mean by more and more precise? Now we are actually going to locate the electron in the atom, and that will help us to develop a new kind of a electronic configuration. So the electronic configuration that you have studied in a lower standard is actually based on Rutherford and Rutherford's model, we can say. But now some of the theories which we are using, that will develop a new kind of a electronic configuration. But to understand the position of electron around the nucleus, there are certain concepts. So now we are assuming electron is a wave. Electron is following a wave nature. Now when an electron is following a wave nature, then what are the things associated with that? So frequency, wavelength, amplitude, and obviously it has a energy which is equal to h nu, that is quantized energy. Now to explain that quantized, the Planck has put forward the Planck's quantum theory, and as we know that this theory could explain black body radiation in a very well manner. But to understand the radiations after the ejection of electron, after the light absorbs energy. So clearly we have two types of spectrums now. One is the absorption spectrum and the other one is a emission spectrum. Now what do you mean by absorption spectrum? In an absorption spectrum, a light radiations or the radiations are absorbed by an electron, and therefore in the background, if we observe, we won't get a band for that radiation, for that wavelength. So let us assume a white light is passed, and let us assume a red and yellow light is absorbed by a substance. Then in the background there are two lines missing, means we have a dark bands over there. There is absorption spectroscopy. Well, in an emission spectroscopy, light is absorbed by substances and it goes to the excited level. Because light consists of, or the radiations have a particular energy, it goes to the excited state. Now in an excited state, it is unstable. So what will happen? It will come down, but emitting certain radiations. So that is called as a emission spectrum. So absorption spectrum and emission spectrum. In current scenario, the absorption spectrum is actually the concept of gratings, kind of a substances which absorbs light, and a color which we are observing for a particular substance is because of the emission spectroscopy. So all these concepts we need to understand why the electron get excited, why the particular substance has a particular color, and that color exists due to the excitation of electron. So how that excitation of electron is taking place, that need to understood by these concepts. Now for atomic structure level, we are not going in detail about that, but in inorganic chemistry, whenever we are dealing with a color for a particular substance, we have to understand this concept. Now the concept today we are going to discuss, that is photoelectric effect. Now what do you mean by photoelectric effect? A simple meaning. Photo means light, electric, the electric current is generated because of light is incident on a metallic surface. So there are so many aspects why metals have a luster, right? Why certain substances have a color. So we can say that concept, that why a particular substance has a color, or why metal ejects electron, okay, lies, the theory behind it is a Einstein's photoelectric effect. So photoelectric effect. So here we are not dealing with the color part, but we are dealing with the current which is generated because light is incident on a metallic surface. Many metals have low ionization potential, that means they have a tendency to lose electron. Now, according to the Einstein concept, light consists of photon. Now, such light incident on a metallic surface, what will happen? The energy is absorbed by the electron and therefore the electron get excited, and once the electron get excited, it will eject out. When it eject out, it is in the form of current. So this is depicted here in the diagram. A metallic surface, radiations are incidents on metallic surface. Now those radiations has a particular wavelength h nu. So I will write here E is equal to h nu. Now this E stand for energy, h nu Planck's quantum theory. So what do you mean by this? This stand for incident radiation energy. Okay, incident radiations energy or energy of incident radiation. Now, what main thing Einstein highlighted, that as soon as the light is incident on a metallic surface, electron never ejected immediately. It absorbs certain energy, it get excited and then it eject out. That means certain minimum energy has to be supplied to that electron so that it get excited. That energy is called as work function, W, and it is represented by h nu 0. So that is called as work function. It is also called as sometimes threshold energy. And the frequency associated with it, that is this, is called the threshold energy. Certain energy is absorbed by the electron, that is W, and now when it achieves that threshold energy, whatever the extra energy is there, that is used to convert, to increase its kinetic energy. So we have a kinetic energy because electron starts moving now, electron ejected out. So that kinetic energy is equal to half mv square. Mass of the electron is the velocity of the electron, kinetic energy. So in short, I can say now that E, so it's very simple law of conservation of energy, we can say E is equal to what? W plus kinetic energy, means h nu is equal to h nu 0 plus half mv square. This is the Einstein's photoelectric equation. I can convert this equation in a very simpler way. that half mv square is equal to h into nu minus nu 0. Now if you observe carefully, to eject electron, I should have a nu, the frequency of radiation should be greater than threshold frequency. Then only the electron can eject out, which we have seen in this diagram. Okay. So this is Einstein's photoelectric equation. Now we know that nu is equal to c upon lambda and nu 0 is equal to c upon lambda 0. Therefore, half mv square is equal to hc into bracket 1 upon lambda minus 1 upon lambda 0. So, if we know the wavelength, we can calculate the kinetic energy. So, this way we can convert this Einstein's photoelectric equation in a various form, but the basic principle over here is this only. So, these equations will help us to understand the concept of photoelectric effect. So, now we will solve one problem based on it. So, now we will solve this problem. Calculate the kinetic energy of electron emitted by an atom by 500 nanometer light when its threshold wavelength is 600 nanometer. So, what we have to calculate? Kinetic energy. It's a simple straightforward problem. We need to use this formula. So, we need to calculate kinetic energy, that is equal to hc, that is, I will write here only hc only, into bracket 1 upon lambda, that is the light incident, frequency of incident radiation, that is 500 nanometer, minus threshold energy, threshold wavelength, that is lambda 0, 1 upon 600. So, kinetic energy is equal to hc into bracket, so this becomes 100 divided by 30 into 10 raised to 4. Okay. So, kinetic energy is equal to, if you solve this further, you will get the answer. Now, here the answer unit for this is joules. Okay. So, it's very simple calculation. This is one of the simplest problem to understand how can we get the answer. Now, here there are so many things associated. So, what kind of a problems they may ask you? They may ask you to calculate frequency of incident radiation. They may ask you to calculate threshold frequency. They may ask you to calculate the velocity of light or velocity of incident radiation. So, then they may ask you to calculate the kinetic energy if some of the things are missing. So, this way the various combinations they can ask. Basically, this approach you people will be studying in a physics also. So, many times problem based on this are there in a physics. In a chemistry, in this chapter, such kind of problems are very less. There is one more problem that will help us to understand what do you mean by when we are applying a potential, what will be the condition, what will be the stopping potential, what do you mean by stopping potential, that also we have to understand. So, that we will see in the next session. Thank you.